Well, good morning, everyone, or maybe good afternoon or evening, depending where you're joining us from. Welcome back here to the launch pad for another live launch coverage. Today, we are waiting for Rocket Lab to get underway as we count down just now under 25 minutes and counting until launch of the 31st Electron mission for Rocket Lab from Launch Complex 1B in the Māhia Peninsula in New Zealand. If it's your first time here, though, welcome. My name's Zach. I'm the founder and host here at the Launchpad, and here at TLP, it's our mission to inform and inspire the explorers of tomorrow because we believe that space is better together. And as we get started, take a moment, let us know in the chat where you're watching from. I see we got Teresa in Tucson, Arizona. We got Don in Allentown, Pennsylvania. Stratoblasters in Couchville, Pennsylvania. We've got Joss in Holland. It's great to have you here. Montana's at Kennedy Space Center in Florida. Hope you're enjoying your day there. We've got CMJ from New Zealand. It's great to have you all here with us today. If it's your first time here, though, here at TLP, it's our mission to inform and inspire the explorers of tomorrow because we believe that space is better together, and we bring you full live launch coverage, space briefings, space news updates, exclusive one-on-one interviews, 24/7 streams sometimes, and more. And if you haven't yet, take a moment, engage that subscribe button so you never miss anything else space, and consider joining us over on our community Discord. It's totally free to join. We're hanging out in live comms. There's a few of us in there. I'll be jumping in there throughout today's stream as well, so feel free to join us there. And getting all the YouTube stuff out of the way, make sure you've engaged that like button. It really helps us out. And of course, it's a launch day, so you can get 10% off everything in the TLP shop using promo code LAUNCHDAY. But you're here for a Rocket Lab launch, so let's run through everything we know as we count down 23 minutes 15 seconds and counting until launch, and then we'll be listening into Rocket Lab Mission Control for that final countdown. Today's mission is it Argos up from here. It will be launching a single Giselle satellite for General Atomics, launching from Launch Complex 1B in New Zealand. It'll be launching into a 98-degree inclination, launching up to a position of 750 kilometers sun-synchronous orbit. Now, Rocket Lab will not be attempting to recover today's mission, so the first stage will be crashing into the Pacific Ocean. Rocket Lab's fairings are not reusable, so they are brand new. And weather, we've heard, is looking pretty decent, but we'll wait for another weather update. This is the first Rocket Lab mission for General Atomics, so a new customer for them. This is Rocket Lab's 8th mission already for 2022, the 4th mission from Launch Complex 1B, which came online earlier this year, and as we said, the 31st Electron launch of the Electron series. We're also ranking up that number. We are now at 140 launch attempts already this year for all the space agency. So definitely that number starting to calculate up and get higher, and we'll see, can we break that to 200 by the end of the year? It's going to be tight, but we'll see if we can do it. If you guys have questions throughout today's stream, you can send those to us in the chat by tagging us at the Launchpad, and we'll work on answering those live throughout today's show as well, to the best of our ability. We don't necessarily know a ton about everything from it, but we do know a little bit about today's payload. This is a dedicated launch for General Atomics and its Giselle satellite bus. General Atomics is launching a satellite as a hosted payload solutions mission for the Argos Advanced Data Collection System. This contract was awarded to General Atomics Electromagnetic Systems by the United States Space Force, Space Systems Command, and on behalf of the National Oceanic and Atmospheric Administration. The Argos 4 payload was provided by the French space agency CNES. The Giselle satellite will be controlled and operated by GAEMS during its expected on-orbit lifespan of about 5 years. So that's what we're seeing today. The Argos program that it's part of uses these satellites for wildlife monitoring, oceanography, climatology, marine fisheries, maritime security, monitoring pollution and equipment safety at sea, humanitarian aid, and integrated global Earth observations. On board today is next to the Argos is the Radmon experiment, which, as the name suggests, is a radiation monitoring experiment that will monitor and measure space radiation. Argos 4 will be joining a network of multiple Argos instruments located in sun-synchronous orbits. Its main purpose will be collecting and relaying data from mobile and stationary transmitters around the world. This data will be used to help improve our understanding of Earth's physics and biological environment, including weather and climate, and assist with maritime security, humanitarian assistance, offshore pollution, as well as biodiversity and ecosystems. So it will probably dive in and know more than that. There's not a lot known about the actual Giselle satellite bus itself, other than we know it will be providing power, communications, altitude control, and propulsion for the lifespan of 5 years for this mission. As we count down now, less than 20 minutes and counting. If you haven't yet, take a moment, engage that like button, share out the stream, let people know we are counting down to launch. We should hear from Rocket Lab here in just a couple of minutes to get an update on how the range and weather is looking, but at last look, everything was proceeding nominally. Lots of people joining in. Great to see. Kat from Long Beach. We got Justin in Mississippi. Heidi's in Worcester, UK. I probably said that wrong, but great to have you here. William's in Reno. Ian's in Virginia Beach. We got Philip in Huntsville. Great to have you here. Fat Thor's checking in from Ireland. Great to see you. We've got Awi from South Africa. We got Roger is in New Mexico. Great to have you all here with us today. As we said, if you guys have questions, you can send those to us in the chat by tagging us at the Launchpad. We'll work on answering those live throughout today's stream as we count down now just 19 minutes and counting. Now, many people ask us, and this is still something new, why are we using an L- countdown on our clock? Everyone uses T-. We at the Launchpad use L- when we count down to launches to help you guys have a better, accurate idea of when the launch will occur. The L- countdown clock is basically your real-world time until main engine start and liftoff. A T- clock actually can hold at different times, and we see this with SLS, we saw it with the shuttle, we see it with ULA, with the Delta IV Heavy, and with their Atlas. They have built-in countdown holds to work through operational procedures at certain times. So T- clocks hold, and they can hold for 30 minutes, they can hold for a couple hours. So here at the Launchpad, we've made the decision we're going to use that L- clock as much as we can when relating to an actual liftoff event to give you guys a better idea of how long it is until the rocket will actually fly. So do you still have time to go make that cup of coffee? Yes, you do. So you can always keep an eye on the countdown clocks there. You can see Rocket Lab spooling up their intro video here, so we will patch them in just a moment. But if you're just joining us, welcome here to the Launchpad and our live launch coverage of It Argo's Up From Here, Rocket Lab's 31st Electron mission, launching from Launch Complex 1B in New Zealand for General Atomics, a brand new customer for them who is working with the United States military. Throughout today's stream, if you have questions, keep sending those in the chat. Make sure you've taken a moment and engaged that like button as we'll be listening into Rocket Lab Mission Control. Our live commentary portion will end at this point, but I will be back answering questions through the chat, but then also back during the coast phase as we count down to deployment. Let's listen in to Rocket Lab Mission Control.
And a bright and early good morning from Rocket Lab's Mission Control Center. We are bringing you a live view of Electron on Pad B at Rocket Lab Launch Complex 1 in Māhia, New Zealand. I'm Felicity Powell, and I'm so glad you're joining us for the launch of Rocket Lab's 31st Electron launch, a mission we've called It Argo's Up From Here. The mission is a dedicated General Atomics Electromagnetic Systems Group, supporting the U.S. National Oceanic and Atmospheric Administration and the French National Center for Space Studies. Right now, we are 17 minutes away from target liftoff at 06:09 local time, or 17:09 UTC. Today, we have an instantaneous opportunity for launch, but if we need to stand down for any reason, we do have backup opportunities available in the coming days. Today's launch will be our 8th for the year. This sets a new record as our busiest launch year yet, surpassing our previous annual record of 7 missions. Since April this year, we've also successfully maintained a monthly launch cadence, which we're on track to maintain for the rest of the year. Very exciting stuff. Scheduled for liftoff today, though, is a dedicated launch for General Atomics. Electron will launch the Gazelle satellite carrying Argos 4 Advanced Data Collection System to the Argos constellation on behalf of the U.S. National Oceanic and Atmospheric Administration, also known as NOAA, as well as France's National Center for Space Studies. This mission supports an international program that collects data from about 13,000 transmitters operating around the globe, serving a host of applications including tracking of buoys, fishing vessels and wildlife, collection of environmental data such as ocean temperature profiles, river levels, and even animal heart rates, and observation of ocean parameters such as currents, temperature, and color. Let's hear more about General Atomics and its payload.
Welcome to the launch of the General Atomics Gazelle spacecraft to low Earth orbit. I'm Greg Burgess, Vice President of GAEMS's Space Systems Division. The Gazelle spacecraft is hosting two payloads, the NOAA-provided Argos 4 animal tracking payload and the RADMON radiation monitoring system. We are proud to join our partners at NOAA, CNES, the U.S. Space Force, KSAT, and RocketLab to launch this critical capability to capture, process, and distribute environmental data globally. The Gazelle spacecraft is the first satellite that General Atomics has built as part of our science and weather program. It's based on the same platform we used for the Orbital Testbed 1 satellite we launched in 2019, as well as the base platform for our NASA Thesis 2 spacecraft scheduled for launch in 2024. Lofting the Argos 4 payload will significantly increase the speed and reach of the Argos constellation, joining its sisters in space to collect global animal movement and migration data.
With this launch, the Argos system will be improved and extended, which will benefit all current and future users around the world. There are several thousand individual users or programs using Argos to track more than 13,000 objects today, primarily for wildlife tracking, such as seals, turtles, dolphins, and many more. This also includes ocean applications, including weather stations in very remote locations such as Antarctica and Greenland, among many others. The US is the largest Argos user of 100+ countries that have Argos applications. NOAA Fisheries is the largest US user with more than 30 individual programs for seals, turtles, and many other aquatic species in the Atlantic, Pacific, Gulf of Mexico, Arctic, and Antarctic. NOAA is honored to have been a partner with CNES for the provision of the Argos system since the late 1970s and thrilled Argos 4 will take us to 50 years of cooperation.
For this program, General Atomics is providing a true end-to-end commercial space capability by designing and building the satellite, hosting a payload for our customer, performing all integration and testing, and operating the space system once it's on orbit. We procured the launch service from RocketLab, and we also contracted with KSAT to provide a commercial path for rapidly getting the data to researchers worldwide. We know that our work today will deliver an enduring legacy for many years to come. Understanding the movement and habits of animals helps us better understand the amazing species that we share the planet with, and will help humanity learn how to be better stewards of all life on Earth.
In addition to launching the satellite on Electron, our team in New Mexico supplied the solar panels that will power the spacecraft once in orbit using the very high-efficiency IMM Alpha solar cells, a best-in-class efficiency solar cell that is more than 40% lighter than typical space-grade solar cells. It is now 0556 here at Mission Control, and we're approaching T-minus 12 minutes in the count. Soon, our operators will run through the go, no-go poll led by Launch Director Michael Pearson. Let's throw it over to Mission Control and check in on how we're tracking for launch.
All stations LD on mission, proceeding with the go, no-go sequence. Stage.
Stage is go.
Avionics.
Avionics is going.
GNC.
GNC is go.
VCON.
VCON is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
And LD sup.
LD suffix go.
A go, no-go sequence complete. We are T-minus 11 minutes and 15 seconds and counting. We are go for terminal count at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
And just like that, confirmation from Mission Control that all systems are healthy and we'll be proceeding with the remainder of the count. The T0 liftoff time remains 0609 New Zealand local time or 1709 UTC in approximately 10 minutes time. Today's mission is our 31st Electron launch, but soon enough, another rocket will take to the skies bearing a RocketLab logo. That's right, I'm talking about the Neutron rocket, which will be launching from Wallops Island in Virginia. Recently, we announced a major step in the Neutron development program, selecting NASA's historic Stennis Space Center in Mississippi as the test complex for Neutron's Archimedes engine. Let's take a closer look at that facility now.
Since its formation in 1961, NASA's Stennis Space Center in Mississippi has operated as America's premier propulsion test site and has tested the engines for the Apollo, Space Shuttle, and Space Launch Systems programs. Now, it's also going to be the home of Rocket Lab's Archimedes engine test program, playing a vital role in the development of our Neutron rocket. The Archimedes Test Complex will be located within the larger A Test Complex at Stennis and will include exclusive use of land within a 1 million square foot area for 10 years. The complex will include exclusive use and development of existing industrial NASA infrastructure and the center's A3 test stand to develop and test Neutron's Archimedes reusable engines. By expanding Stennis Space Center to include the Archimedes Test Complex, we plan to bring new, high-tech jobs to the state of Mississippi. At the same time, construction continues at the Neutron Production Complex and launch site at Wallops Island, located within NASA Wallops Flight Facility and Mid-Atlantic Regional Spaceport on Virginia's eastern shore. Combined, the two sites represent over 2 million square feet of operations for Neutron's production, testing, and launch facilities.
This is such an exciting time for Rocket Lab, and we are moving full steam ahead on developing Neutron, which will further open access to space to improve life on Earth.
Stage LD mission.
LD stage.
Proceed with sequence 57, stage terminal checks.
Copy, proceeding with sequence 57.
Stage 1 and Stage 2 high voltage batteries ready for flight.
GC LD mission.
LDGC.
Proceed with sequence 58, launch pad ready.
Roger, proceeding with launch pad ready.
It's now approximately 7 minutes before liftoff, and while today's mission is lifting off from Launch Complex 1, our teams in Virginia are gearing up for our very first launch from US soil in December. Electron has arrived at Launch Complex 2 and is undergoing final integration checks ahead of payload integration and launch. Before we get to launch, though, our team will perform what is known as a wet dress rehearsal, a critical test that we conduct for each and every mission. A wet dress rehearsal is essentially a practice launch day, where the rocket is rolled out to the pad, and we undertake all the same steps that we would on a real launch day, including filling Electron with liquid oxygen and kerosene, hence the name wet dress rehearsal. With the development and production of launch capabilities on Virginia soil, we've got plenty of roles to fill. From developing our new large launch vehicle Neutron to building satellites and their components for constellations and interplanetary missions, there's something for people from all areas of expertise. Over the last year, Rocket Lab has expanded to even more locations across the United States, which means more opportunities to join Rocket Lab no matter where you call home. We'll soon be updating our website with more information about the internship programs available at each of our 9 Rocket Lab global sites. And of course, we are constantly seeking new talent and inspired aerospace professionals to join us in our mission to go to space to improve life on Earth. Let's hear from some of the team about what life is like working at Rocket Lab.
10, 9, 8, 7, 6, 5, 4, engines 3, 2, 1. Liftoff, vehicles get the pad.
Yeah, for me, I just really love the mission of the company. I think as you look at what we do and the challenges we take on, we don't do easy things, so we look for people that are motivated by that. Joining a company that's not just a job, it is part of the mission of what we're doing and trying to make life better on Earth via doing incredible things in outer space.
The reason I joined, I was in a rocket club in college. With a lot of the rocket building in general, it's all kind of scrappy. Let's like make it work. And so you just have all this passion behind it. And so I really just wanted to be part of the industry.
I was excited when I got a position for here. I'm like, oh, now I get to go above in space and see how the great beyond is.
I know it's kind of daunting. Manufacturing doesn't look all that glamorous, but like it really is very, very exciting to take a product and physically work on it yourself and manufacture it, make it work, and then fly it.
Archimedes being the next engine that we're building for Neutron, which is the next rocket, which is going to be integrated and built in Virginia, along with a bunch of other deep space stuff. You know, we're going to Venus, we're going to Mars. It's just it's endless possibilities.
Oh man, every launch feels like you just won the Super Bowl. Honestly, like it's a ton of effort. It's usually like dozens of people putting their effort in over time, and so when you finally see that launch,
it's awesome. Yeah, you could hear a pin drop in the room as we're all watching the launch, right? And it's everybody's tuned in, and we know exactly which parts on every launch.
Neutron is going to be probably one of the most innovative rockets in the world, right? It's unique designs from the structure all the way down to the engines. But beyond that, in Virginia, we're starting from scratch, right? You have the opportunity to really develop something and have a major impact on not only the design of the product, but also the design of the building, the facilities, the process, and the launch complex itself, which to me is an incredible opportunity. I would love to do something like that.
Liftoff, vehicles get the pad.
To find out about our internships and open roles, check out the careers section of our website. As we approach T-minus 3 minutes in the count, we're approaching Electron's auto-sequence start, which engages at T-minus 2 minutes. As day is about to break on Launch Complex 1, the team in range control are tracking no issues with the range, the weather remains clear, and all surrounding areas are within safety parameters. With LOX loading near completion, Electron is almost ready to head to space. Let's hand things over to the team in mission control and listen in to the last few minutes. I'll be back with you shortly.
All stations LD on mission. From now on, there should be no red flags in your critical LCCs. VCON LD mission.
LD VCON.
Confirm all expected flight computer ASGOs are green.
Confirmed ASGOs are green.
Lock auto sequence and confirm.
Confirmed auto sequence is locked.
Okay, all stations, we are go for auto sequence start at T-minus 2 minutes. LD is go for launch. LD shadow, confirm go for launch.
Confirm, go for launch. Vehicles on internal power. AFTS is green and enabled for flight.
LOX load complete. LOX system in research. All helium anti-gas ring disabled.
Stage 1, Stage 2, press for flight.
High flow engine purge enabled. Deluge activated.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3,
Ignition.
2, 1. Liftoff.
Stage 1 proportional, nominal.
T plus 38 seconds and our 31st Electron has lifted off from the pad at RocketLab Launch Complex 1. Electron is powering its way to orbit for General Atomics. The next milestone after liftoff is max Q, or maximum aerodynamic pressure. This is the moment during launch when the forces on Electron are at their peak, causing the most amount of stress on the rocket. Let's listen in for the call from Mission Control that Electron has cleared through max Q.
Cleared max Q.
HV battery discharge nominal.
That's confirmation from Mission Control. Electron has successfully throttled down, passed through max Q and ramped back up ahead of stage separation. We're currently traveling at over 2,000 kilometers per hour and at an altitude of over 20 kilometers. The next 3 milestones happen in relatively quick succession, within seconds of each other. First things first is MECO, or main engine cutoff. The 9 Rutherford engines will throttle down and then shut down completely before step 2 of this sequence. Separation of the first and second stages is next, and you'll see the first stage drop away from the stage 2 body. And lastly, to continue our journey to orbital insertion, we'll see ignition of the single Rutherford engine on Electron's second stage, continuing the journey to deliver the Gazelle spacecraft to its destination.
Fifteen seconds to MECO.
MECO confirm.
Stage separation successful.
Stage 2 ignition.
And with the nozzle extension on the stage 2 Rutherford engine glowing, we've had successful MECO, separation, and stage 2 ignition. Now that we've passed through the harshest part of Earth's atmosphere, we no longer need to protect the payloads, so we can eject the fairing halves to save some mass. Let's keep an eye on your screens to catch a glimpse. You might have caught a flash of it there on your screen. This fairing has successfully ejected. Stage 2 is continuing nominally with its General Atomics payload to orbit. The vehicle is currently at over 120 kilometers of altitude and reaching speeds of more than 8,500 kilometers per hour.
Guidance is nominal.
Stage 2 propulsion is nominal.
Everything is looking great at the start of our stage 2 burn. That nozzle extension is glowing red hot as Electron powers through space at over 9,000 kilometers per hour. You'll see on the right of your screen those propellant levels depleting slowly, with about 76% of liquid oxygen and 75% of RP1 kerosene remaining. If you're just joining us, we're live for our 31st Electron mission at Argo's Up From Here for General Atomics. After a successful liftoff at 0609 local time, we're in the first part of our Stage 2 burn. And in case you weren't aware, this week is actually World Space Week, an international celebration of the space industry and the part it plays in the future of humanity. The theme for this week is space and sustainability. This mission for General Atomics contributes to global sustainability by enabling scientists to monitor the behaviors and health of wildlife. Follow our social media channels for more World Space Week updates. Those familiar with our 3D printed engines will know that Rutherford engines use batteries to power their propellant pumps. But, much like anything that runs on batteries, that power source gets depleted, and soon a fresh battery is required to keep things going. The process of switching out this power source mid-flight is what we call the battery hot swap. You should see the battery packs falling away, that shiny silver object on the right of your screen. So let's listen in for the call out from Mission Control.
Stage 2 propulsion still nominal.
Hot swap successful.
And battery hot swap is confirmed. The Stage 2 engine is powering the General Atomics payload to its destination orbit at 750 kilometers above Earth at an inclination of 98 degrees. No, not the 90s pop group, but a Sun Synchronous Orbit, or SSO. This allows the satellite to be positioned over the same location on Earth at the same solar time every day. We're well above the Kármán line now and on our way to orbit. Just before, you might have seen the battery hot swap, where we switched out the depleted batteries from feeding the Rutherford pumps on the second stage engine with a new one. The pumps are driven by an electric motor which provides fuel and oxidizer to the combustion chamber, spinning at a rate of over 42,000 RPM. The vehicle with payload is healthy, currently traveling at speeds of over 18,000 kilometers per hour and at an altitude of over 290 kilometers. This launch marks our 31st mission and our 8th for this year, which is now our highest number of launches in a year, and we still have plenty of 2022 left. As I mentioned earlier, our first mission from LC2 in Wallops, Virginia is slated for the end of this year, and we're all very excited to baptize our third launch pad in fire from those 9 Rutherford engines. A quick update from Mission Control for our 31st Electron mission at Argo's Up From Here. Electron is cruising at a speed of over 22,000 kilometers per hour, and it's in an altitude of just over 300 kilometers. With just a 10% LOX remaining and 10% RP1 remaining, we're coming up on SECO or second engine cutoff ahead of kick stage separation.
Guidance on toner, 27 seconds remaining.
SECO confirm.
Nominal transfer orbit.
Stage 3 separation confirmed.
Much like main engine cutoff, the Stage 2 Rutherford has now throttled down before the stage separates from the kick stage as it continues on to payload deployment in the next 40 minutes or so. You've seen it on your screen. The Rutherford engine on Electron Stage 2 successfully throttled down, and Stage 2 and the kick stage now have separated. The kick stage will now enter what we call a coast phase. For the next 45 minutes or so, the kick stage will be in an elliptical orbit around Earth before the Curie engine ignites and raises the kick stage's perigee to put us in a circular sun-synchronous orbit we mentioned earlier in the broadcast. From here, we'll deploy General Atomics' Gazelle satellite. We won't have live video feed from kick stage of payload deployment on this mission, but we will stay with you on this webcast to bring you a simulated view of this process. While we're in this coast phase around the Earth, we'll also take a bit of a break on the webcast, but we will be back with you closer to payload deployment to listen in on those final moments from mission control, with payload deployment expected to take place at about T plus 55 minutes. I'll see you back here soon.
And if you're just joining us, welcome here to the launch pad. And as you can see, we've had a successful launch of RocketLab Electron's on its 31st mission. It Argo's up from here. You can now see on your screen a countdown to estimated payload deployment expected at T plus 54 minutes, 58 seconds into flight. So we're going to stay live throughout this time so you can track where that third stage is as it goes through its coast phase and has a burn coming up in a little bit. We expect to have that Curie burn at 51:26 minutes. So about 40 minutes from now. But in the meantime, we're going to answer your guys' questions live. So you can send those to us in the chat by tagging us at the launch pad, and we'll work on answering those. If it was your first time here, though, welcome. My name's Zach. I'm the founder and host here at the launch pad. Here at TLP, it's our mission to inform and inspire the explorers of tomorrow, because we believe that space is better together. And you make sure you've engaged that subscribe button so you never miss another live launch coverage, space briefing, space news update, or exclusive one-on-one interview. And we have a very large announcement coming out sometime this month, hopefully in the next couple of weeks, of something that you're all going to want to be able to check out. So make sure you're subscribed, following us on Twitter to get some teaser updates on it. But we're very excited to have this announcement coming very, very soon. But as we count down about 42 minutes or so to deployment, we're going to answer some of your questions. You can keep sending those in the chat. But right off the bat, we've got Klaus. Is the speed they show always relative to the surface, or does it switch to relative to the Earth's core once they pass the Kármán line? That is a really great question there, Klaus. That would be, I believe, to the surface. They would not switch speeds. That would just throw too many things. It'd be too confusing to do that. So that would be staying to the speed. Just like a car or a plane does, it's all at an equal measurement. But great question there. MTL Aerospace asking, is the first stage going to be recovered? So not today. They are not going for a recovery. If they were, we'd be watching a helicopter feed right now. They did that one recovery early this year where they caught it but then had to release it. And they have not done another recovery attempt yet. We were actually talking about this in the TLP Discord earlier this morning. If you guys want to join that Discord, you're more than welcome to. The link's there in the chat. It's totally free to join. But we have not seen them go for another recovery. They keep saying they're going to, so they're definitely working out that procedure. It's not easy to catch one out of the air. It's very different than just recovering it via parachute and scooping it out of the water. So we'll have to wait and see. Maybe by the end of the year we'll see another one. If not, early next year, I expect to see one. John Fairs, why don't I get notifications of launches? I'm not sure why that's not going through. If you ever have that issue, next to your subscribe button, there's a little bell. Sometimes it works to turn all your notifications off, refresh the page, and then turn all your notifications back on. Sometimes that's just a YouTube thing, so we'll see what happens. Don, thank you for the stream. Absolutely. Thanks for being here. If you guys have questions, you can keep sending those in. Federico asking, what does the map show? So this map right now is showing this current location of the third stage, which is carrying the payload right now. It normally has a little symbol on it, but if you look on the kind of 2/3 of the way across your screen, there is a white line traveling. Oh, actually, you can still see the little thing. There's a little capsule looking kind of emoji over Antarctica right now. Because it's white, it blends in pretty well. But that is slowly traveling to the west, so you can see where the payload currently is, and we'll follow that along until we have deployment just under 40 minutes from now. Lynx, is this actually live? This is live. Yes, it is. Dominic's asking, do rockets deplete our planet of oxygen? I mean, to have flame, there's always the burning of oxygen, but for a lot of engines, that oxygen is provided by the rocket itself, so it wouldn't actually be burning the oxygen right around it. Of course, any flame, there's always going to be a little bit of burning, but nothing to a point that you would ever need to be concerned about for it. Rockets are actually, generally speaking, rather efficient, especially newer modern rockets, so not really an issue to worry about the rockets impacting our oxygen or CO2 or anything sort of there. Ted S. pointing out, closing in on that 100K subs, time for a party. We really are. We're past the 95K mark, thanks to all of your generous support of being part of this crew, and we're glad to have you all here. If you haven't yet, make sure you engage that subscribe button, and our team's working on some big plans for a 100K celebration, and we're hoping a bunch of us are going to be together for it in Florida. Of course, there'll be a live stream. We're going to put out a couple special edition shirts that'll be available for a very limited edition time, and some other things. Make sure you stay tuned for that. There's also going to be some giveaways, but stay tuned. There's going to be stuff for our members exclusively as well. So if you're not a TLP member, consider hitting that join button or heading on over to our Patreon, and stay tuned for that. You'll get to see a little bit of behind the scenes as well of our 100K celebration. David's asking, did they launch? Yes, they did. 16 minutes ago. They had a successful liftoff, and we actually wanted your guys' feedback. We've tried this out yesterday with Crew 5, and we're doing it again today. Right now on your screen, there's actually two clocks. One is the clock since liftoff, and one is the next major event. So right now we have it on payload deployment. We could switch that to when is the next burn of the engine if we wanted, but we want to hear from you guys. Do you like having the additional clocks on the top? Do you want to have just one additional clock with payload deployment, which is the end of the mission? Or would you want to see that clock switch to the next major event, the next burn or something? Let us know in the chat. Next burn, payload deploy, or rather not be there. We'd love to hear from you guys. We want to be able to provide you guys the best possible coverage of everything space and do it in a way that is assisting to you. So let us know in the chat there. Derail, are the batteries, do they leave orbit toxic? No, they would burn up in the atmosphere for it. So they wouldn't be too bad. I mean, obviously it's a battery. There is chemicals and stuff in it, but through burnup, it wouldn't be that major of an issue. They're also very small batteries. When you look at the size of Electron next to a person, this is a very small rocket. So think of it like little batteries you have at your house. They're not batteries like the size of, a shipping container or anything. So they're rather small. If you're just joining us, though, you're looking at a live tracking view of Rocket Lab's third stage for their mission at Argo's Up From Here. We had a successful liftoff from Launch Complex 1B in New Zealand just under 18 minutes ago, and we're counting down now just over 36 minutes to payload deployment. We're answering your guys' questions live. You can send those to us in the chat by tagging us at the launch pad, and we'll be answering those for here. If you want to jump the queue and be the next question, send it in as a super chat, though, and you'll be the next one that we answer. And, of course, thank you for supporting us in that way. It helps us bring you guys the best possible coverage of everything space. Rebecca's asking, will any update on Artemis will launch? Not yet. We have reached out to NASA and had some updates from them over the last couple of days. Teams are continuing to work on SLS in the vehicle assembly building. They're continuing to inspect the pad and the crawlerway. At this time, they're also trying to make sure that their teams are able to support their families, as many do not live directly in the Space Coast region, and some were impacted by Hurricane Ian. So they're wanting to make sure that they also have time for family that need to be at home taking care of their family to do so and working those schedules. So they are working it. They are, at this point, needing at least another week or so before they really start locking down a date for rollout. But they are already in conversations with the range to secure launch dates. So we know the launch window. But now NASA is already in the process of selecting target launch dates, and we hopefully will hear about those in the next 2 weeks. So make sure you stay tuned for those. Kieran and I are going to do an Artemis kind of update / ask us anything once we have some more information. So stay tuned for that live stream, and we'll be answering all your questions on Artemis then. Just catching up on all of your questions here. You can keep sending those in the chat. John, second stage deorbited? Yes, the second stage will deorbit. I believe that it deorbits by itself just within time. Ship hacks. I'm probably saying that wrong. Sorry about that. Why is there no camera view on the front of the rocket? So right now we're over the middle of Antarctica, which means we do not actually have like a ground station for live telemetry. So the rocket's in a coast phase by itself, navigating by itself. So we, even if there was a camera, which there is a camera on board, we would not be able to see. Because we don't have a way to download the satellite to have that data connection. You can see those red circles on the map. Those are some of the communication parts where they can acquire downlink as Electron travels. So we're going to be waiting. We might get just a little bit of data when it hits the southern tip of Africa. But once it's back over Africa and Europe, that's where we'll get a solid downlink. And we'll probably see another live view of the rocket engine or possibly the payload as well. So we'll be keeping an eye on that. Because it is a payload for the military, there always is the possibility they have requested the payload not to be shown, and we'll just have a simulation. We also do know we won't have a live view during actual deployment, but we will have a simulated version of that deployment as well. Ooh, drop a poll. That's a good idea. Let me do that. There we go. We got a poll in the chat there for that question again. We want to hear from you guys. What do you think of having the secondary clock? Would you like that secondary clock to show the next major event, the countdown to deployment, or would you rather it not be there? So let us know in the poll. That's going to help us set that up to be better for you guys. Edwin I've seen asking about Artemis as well. Stay tuned for an update video live stream with Kieran and I where we'll be answering all those questions once we know a little bit more. We're hoping to do that in the next week, 10 days or so. If you're just joining us, though, take a moment and share it in the chat by tagging us at the Launchpad, and we'll be answering those in there. Kieran dropping a super chat. Thank you so much. You're part of our team, though, Kieran. I don't have a question, but I'm just hyped that we'll hopefully be hitting 100K while we're all together in Florida. The sport is astronomical. It really is. I'm so excited that we're heading back. Our team is making those plans and looking at everything. We're excited to be back on site for another launch attempt of Artemis 1 to bring you guys coverage live from on site. We'll do another TLP meetup opportunity. So if you are in the Florida area, keep an eye out on Twitter because we will probably give about 24 to 48 hours notice about somewhere we're going to be hanging out for a couple hours, and we invite you guys to come see us, say hello, want pictures, whatever. We'd love to meet you guys there. And if you come find us at any point while we're in Florida, we will give you a link to get an exclusive TLP 2021 Artemis Meetup tee, which means you saw us during the Artemis campaign. So you'll have an opportunity to be able to buy that shirt only if you come find us in person. If you see us roaming around, we love seeing you guys. Come say hello. It's not you don't have to be scared of coming and seeing us. We would love to meet you guys. You guys let us have the pleasure and opportunity of doing this as our jobs, and we're eternally grateful for that, and we love to meet you guys in person. Dominic asking, are they planning on sending a woman to the moon? Absolutely. So Artemis 2 will have 4 people on board that will go into orbit. It'll be 3 Americans from what we're hearing and 1 Canadian. There's a possibility that one of those Americans will be replaced with a European. So 2 to 3 Americans, a Canadian, and maybe a European on Artemis 2. That orbits the moon. Artemis 3, the one that actually goes down to the moon, will have the first person of color and the first female going. And the first person of color and first female will, of course, be 2 of the 4 people on the crew. But those 2 are the ones that will be going down to the surface. So they're going to be picking that crew here. We should hear about the Artemis 2 crew by the second half of next year. So we're within a year of knowing the first crew that'll be back in orbit of the moon, which is really, really exciting to see. We've got a question coming in. Are SpaceX going to have another go at last night's scrubbed Galaxy mission? From what we've been hearing, yes. We're waiting on them confirming an attempt today. But from our understanding, yes. There was a small helium decay leak detected. Elon confirmed very shortly after the scrub that leak was almost to the point where it didn't even trigger the alert for it, but it did. And because it's a customer mission, they always take safety first and security of the payload. If it was a Starlink, they might have gone. But because it's a customer, they never risk that. So they scrubbed, had teams review the vehicle, and we are expecting another possible launch for that this evening. And of course, we'll bring live coverage of that once we have confirmation. We do have that stream already scheduled, so you can go hit set reminder, and we will see you for that as well. If you're just joining us, though, welcome here to the launch pad. We're now 27 minutes since liftoff of Rocket Lab's 31st Electron mission from Launch Complex 1B in New Zealand. We are counting down about 27 minutes to payload deployment of today's single satellite on board for a brand new customer for Rocket Lab. Their mission, it Argos up from here, is their first mission for General Atomics. And we'll run through a little bit about today's payload again, and then we'll keep answering your guys' questions. So you can send those to us in the chat by tagging us at the launch pad, and we'll answer those. But today's mission is a dedicated launch for General Atomics and its Giselle satellite bus. General Atomics is launching the satellite of a hosted payload solution mission for Argos Advanced Data Collection Systems. The contract was awarded to General Atomics Electromagnetic Systems by the United States Space Force, Space Systems Command, and on behalf of the National Oceanic and Atmospheric Administration, or NOAA. The Argos 4 payload was provided by the French space agency CNES. The Giselle satellite will be controlled and operated by General Atomics Electromagnetic Systems and is expected to have a lifespan of about 5 years. Next to the Argos 4 is a RadMon experiment, which has been attached, which, as the name suggests, is a radiation monitoring experiment that will monitor and measure space radiation. Once on orbit, Argos 4 will join a network of other Argos instruments located in sun-synchronous orbit. The main purpose for Argos 4 will be collecting and relaying data from mobile and stationary transmitters around the world. This data will help improve the understanding of Earth's physics and biological environment, including weather and climate, assist with maritime security, humanitarian assistance, offshore pollution, as well as biodiversity and ecosystems. So that's what's on board today. Not a lot's known about the actual General Atomics Giselle's satellite bust. Other than that, it will be providing the payload and experiment, their power, communications, attitude control, propulsions, and this has that lifespan of 5 years. So that's what we are waiting for payload deployment there. You can see that third stage of the Electron now starting to make its way up the southern Atlantic Ocean, offshore, off the west coast of Africa. And we should have downlink possibly pick up here very lightly. Could be spotty for the next few minutes, but then once we're over Europe, we'll have a secure connection again and hopefully have another live view of the pad, or of the third stage, excuse me. John Ferris, Zach, will the Philippines ever be included in the space program again? Great question. Big question for the Philippines. That all comes down to what type of programs they want to run. What's their space programming for it? If they wanted to sign the Artemis Accords and be part of the Artemis program, there is that option, but there also is a level of expectation on kind of spend and what they would be able to bring to the program. So absolutely, there's always a place for more countries to sign on to the Artemis program and Artemis Accords and get back into kind of the space industry. But that would really more be reliant on their scientists, their engineers, and their country government on where they're spending their money. They could launch a satellite on SpaceX or RocketLab or whoever if they spend the money. These companies are kind of like, if you think about Uber. You know, you need a ride, you book one. That's exactly what RocketLab and Falcon 9 with SpaceX now are. You need a ride to space, you just book one. And then they'll work it into the schedule and availability and all that, but you're going to pay for it. So that's what we're seeing there. A great question. Thanks for sending that in. Kieran, 2 Americans, 1 Canadian, 1 European. If we forget the fact that the UK isn't in the EU anymore, we have a picture. We have a picture with 2 Americans, 1 Canadian, and 1 Brit. Can we be that crew? I don't know. Let's see how Artemis 1 goes first, and then maybe we can volunteer to be the Artemis 2 crew. But it's true, we do fit the staple. We do fit it. So we'll have to see what happens. But maybe Artemis 5 or 6. We'll see. We'll see. We know we're going up one day. That's for sure. Question coming in from Valerie. When will they attempt recovery? Yeah, it's been, it was really early this year they attempted to do that with the helicopter. They keep saying they're going to try to do it again, but they've been doing a lot of customer launches, and they're wanting to focus on making sure they do a successful launch rather than focusing a lot on recovery. So they are going to do recovery again. We'll most likely see something very end of this year or early next year where they'll do another attempt. Their teams are still working on it. So because they caught it last time but then had to drop it, I think they've gone back to the drawing board on like the math of how they need to do it and all the loads and strain on the helicopter, and they'll be going from there. But there is still that chance that they will be able to recover from a helicopter in the future. And if not, there's still the chance that they can recover from the water. It's just a bit of a longer recovery process, so we'll have to see what happens there. If you haven't yet, though, take a moment, engage that like button. I know it's an extra step to do, but we really do appreciate it and really does help us out. Lets YouTube know that you're enjoying the stream. And if you happen to be catching this on the replay, meant to say this at the beginning, let us know in the comments below replay. We always love to know who's watching later. We're coming down to now just about 20 minutes until payload deployment, so we're going to take a quick commentary break, and I will be back just prior to that startup of the kick stage Curie engine, which is expected at T plus 51 minutes, or about 15 minutes from now, right ahead of payload deployment. So stay with us right here on the launch pad as we count down T minus 20 minutes until payload deployment of today's Argos satellite. Stay with us. And if you're just joining us, welcome back here to the launch pad. We are now just about 90 seconds away from expected payload separation of today's mission for Rocket Lab. We're just waiting for confirmation from the teams in Rocket Lab to hopefully patch us back into mission control here. We're still getting music on their end, but we should have seen that kickstage Curie engine ignite about a minute ago, and are now waiting for that payload deployment to occur in just about a minute or two from now. If you have any last minute questions, you can send those to us in the chat by tagging us at the launch pad, and we'll work on answering those. If you haven't yet, take a moment and engage that subscribe button so you never miss another live launch coverage, space news briefing, space news update, or exclusive one-on-one interview. Should be coming up to that payload deployment here. We'll wait for confirmation, hopefully from Rocket Lab. We should still be deep into that burn.
To the webcast of Rocket Lab's 31st Electron mission, it goes up from here. If you're just joining us, today's launch included a successful on-time liftoff at 0609 New Zealand local time, or 1709 UTC. At T plus 2 minutes 23 seconds, we had MECO off the 9 Rutherford engines on Electron's first stage. 3 seconds later, stage 1 and 2 separated, followed by stage 2 ignition at 2 minutes 29 seconds into the mission. We experienced a successful battery hot swap, followed by SECO at T plus 9 minutes and 8 seconds, and kick stage separation a few seconds after that. The kick stage has completed its first pass in an elliptical orbit of Earth, and a few minutes before we came back to this broadcast, our Curie engine on Electron's kick stage ignited and burned for 23 seconds to position the kick stage in circular orbit, so we can deploy the General Atomics satellite on board. Let's listen in to Mission Control for confirmation of payload deployment.
There we go. Payload deployment confirmed.
Nominal orbit.
And there we have it. Payload deployment confirmed. Today's mission officially completed. Electron completing its 31st mission, successfully deploying that single dedicated payload mission into orbit. And you heard following there, nominal orbit confirmed as well. Let's listen back in.
151. Congratulations and thank you to our customer, General Atomics, NOAA and SENES, for a successful mission. And congratulations to the whole Rocket Lab team. A huge thank you to you at home as well for tuning into the live stream of Rocket Lab's 31st mission. We're going to end the broadcast here, but remember to follow Rocket Lab's Facebook, Twitter, LinkedIn, and Instagram pages for information on our next mission next month. We'll leave you with a song aptly called Electron by Sweet Mix Kids off their recently released album, Stargazing. Thank you again for joining us. My name is Felicity Powell, and this is Rocket Lab Mission Control, signing off.
And I'm sure that song's going to be amazing, but I'm pretty sure it's copyrighted, so we're going to mute it there, and we're going to do our wrap-up. But if it was your first time here, welcome here at the Launchpad. We provide full live launch coverage, space news updates, space briefings, and exclusive one-on-one interviews. And this has been our live launch coverage of today's It Argo's Up From Here mission from Rocket Lab. If you haven't yet, make sure you've subscribed that button so you never miss another launch live. Consider joining us over on the TLP Discord. The link is in the chat there. And follow us over on Twitter to never miss space news as it happens. As we said, we got a big announcement coming up in the next couple of weeks on something each and every one of you are going to be able to use, and we can't wait to share that with you soon. We're expecting to have possibly another SpaceX Falcon 9 launch attempts for those 2 Galaxy satellites later tonight, so make sure you stay tuned for that. And we've got a number of more launches still this month. 3 more Falcon 9s on the schedule. We got a couple Soyuz, we got Virgin Orbit, and possibly even a couple test flights of some new rockets as well. So make sure you're staying tuned for all those updates. But here at the Launchpad, it's our mission to inform and inspire the explorers of tomorrow, because we believe that space is better together. And this is Zach from TLP Network Studios signing off. I'll see you next time. Bye-bye.